you just drop it, and then the other one, typically you throw it up in the air, but you could also be having a bad day, and you go, "Argh," and you throw it down, okay? So there's two options. You can throw it, you can drop it. In both situations, we're going to maintain the same system. Gravitational acceleration is going to be negative 9.80 meters per second squared. Technically, that changes depending upon where you are on the Earth, but that's just a good working number. Key point of that is that that has three significant digits, negative 9.80. If you go to the top of Mount Everest, it's actually a little bit less because you're further from the center of the Earth. We'll deal with that later. On all of these problems, we're going to define up. I don't care if it's displacement, velocity, acceleration. Anything going up is going to be positive. Anything going down is going to be negative. That way you don't have to guess. It's like, oh man, how are we going to play this one? We're all going to play them the same way. Okay? So we're going to go through the drop first, and then we'll deal with the throwing after that. So let's start off with something simple. And by the way, if you throw something up in the air, and this is going to be important later on, when it's at its highest point, the velocity is going to equal 0 because it's changing the direction.
What's the, for the throw, it's V naught?
V naught could be a positive or negative number, depending upon which way you throw it.
But what's the T and the, like,
It's
R
either
or-
positive or a negative
Or
number.
negative?
Yeah.
Oh.
Depending upon which way you throw it.
That's a plus or a negative.
Yeah.
I see. I thought that was T or
No,
minus a number.
No, plus or minus. All right, so here's going to be the story. So I'm going to hold up this tennis ball to a height of 2 meters, and I'm just going to drop it. Okay? Just going to drop it. So the height that it's going to fall is 2 meters. Okay? So all the numbers that you need is that it's going to fall to a height of 2 meters. So I want to figure out how long it's in the air, how fast it's going when it hits, and then I want to draw a velocity, time, and a position time graph. Okay? Now, let's start with this. So here's your visual. I've got it up to a height of 2 meters. I want to drop it, boom, it begins to fall. So this will make sense later on. We're going to deal with something known as the concept of Jedi Stoffelwatch. Stoffelwatch stands for stop the force and watch. So if I stop applying the force from my hands and I watch what happens, what does it begin to do?
Fall.
So it begins to accelerate. The only way something can accelerate is if there was an external force acting on it. So it's like, oh, does the Earth still have gravity? Yep, it does. Okay, can't see it, right? But it's there. Once we're going to spend a lot of time talking about gravity, this will make sense later on, for why we thought gravity was magic. Mainly because of the fact that I drop it and it falls, but yet there's no force that you can see acting on it. It's like, oh, it's magic. Okay? Now it makes sense, because if I let go of this and it floated up towards the ceiling, what would you say?
Uh-oh.
It's magic, right? If it goes up, it's magic. If it falls down, it's gravity. One direction is like, oh, you're a sorcerer, burning the stake, and the next one, oh, it's just gravity. Just depends on which way the ball falls. Okay, so let's start with the velocity time graph. Where's the velocity time graph going to start?
0, 0.
0, because I'm going to drop it. I'm not going to throw the ball down. I'm not going to throw it up. I'm just going to drop it. Okay? So my velocity is going to start at 0. You got one of two options. It's either going to slope up or it's going to slope down.
Gives you reference above the ground or your hand.
Doesn't matter.
Well,
Slope up?
going down. No, it might be down.
Maybe down
Or slope down?
It's
Because it's
down
speeding up with
because it's
acceleration.
up and acceleration is negative, so.
Ah! And every problem, which direction are we defining down as acting? Negative, right? Irrespective of reference point, down is going to be defined as being a negative value. So what's the value of the slope of that line? negative 9.8 meters per second squared. Cool with that? Got it, Randy, no worries. Okay? So here's what's going to be important in terms of a big idea, and this is going to get to what you talked about with the reference point. If you were to find that area, what would the area of that be? Displacement. But it would be a negative velocity multiplied by some value of time. So what would the sign of my displacement be? Negative. So this area has to be negative 2 meters. No matter how I set things up, my area has to be negative 2 meters. Because that's the slope of my line. Down is being defined as negative. My slope is negative 9.8 meters per second squared. My area then has to be a negative value. That's going to play out huge later on. Now, when it lands, I don't care about the numeric value. I don't care about the number. What's going to be the sign of the velocity at impact? No. The sign when it hits the ground. It's positive or negative. Which one? Negative. Look at your velocity time graph. So when that hits the ground, my velocity has to be a negative number, because we're defining down as being negative. Now don't get nitpicky and go, oh, it's going to be 0 because it hit the ground. Shut up. It's how fast it's going when it hits the ground. Okay? Don't get hung up, oh, it's going to be 0. Stop. It's how fast it's going when it hits the ground. Okay? All right. So let's talk about how long it's going to be in the air. So if you look at the V naught tax chart, what do you know?
Acceleration.
I know my acceleration is what?
9.8.
Negative 9.8 meters per second squared. Cool. What else you got? I know my initial velocity is 0 because I'm dropping it. Okay? I'm not throwing it, I'm just dropping it. What do you got for any other variable?
Distance.
Now, I'm just going to put this as 2 meters for now. We'll deal with that later. Time is an unknown, and my final velocity at impact is my unknown. Okay? So let's deal with time first. So since I'm trying to find time, what equation do I not want to use? That equation. V squared equals V naught squared plus 2AX. Don't want to use that equation. Why? It doesn't involve time. It gets me nowhere. Okay? It gets me nowhere. So that leaves basically either in V equals V naught plus AT or X equals 1/2 AT squared plus V naught time. How do you want to roll it?
Do the bottom one.
Why not the top one?
Because there's two of them.
I have 2 unknowns. What do I not know? I don't know the final velocity, nor do I know time. Okay? So that leaves me with the function equation. Do y'all ever watch like conjunction, junction, what's your function? Okay. If you never know that, you completely missed out on life. Okay, so we're just going to call this the function junction equation. So, because I'm dropping it, what's my initial velocity? 0. So this whole part of the equation goes away. Isaac Bruce, I've got X equals 1/2 AT squared. I need that equation solved for time. And I hate fractions. What am I going to do? Keep going. Multiply by dose. Then what? By? No.
The acceleration negative 9.8.
Just divide by A. Don't get crazy with numbers.
Okay.
And that leaves me t squared, and how am I going to undo the t squared?
Square root of it.
Yeah. Now, this is not a big dog equation. It's a pup, but it's a grand equation. But you can only use this equation under one circumstance, and that's if your initial velocity is 0. If I throw the ball down or if I throw the ball up, I can't simplify this because that v naught t part of the equation wouldn't go to 0. So this time equals the square root of 2x over a. It's a great little equation, but choose wisely when you use it, okay? I say again, choose wisely, okay? All right,
How would you solve for t if,
you have to use it, you'd have to solve it as a quadratic.
are we gonna do that?
No,
Make it,
not for what? We'll deal with quadratics, just not this. Now, listen to me. What I'm going to do is wrong, okay? Do not do what I'm about to do. Oh, okay, I got this. Camp physics is easy. 2 times 2 meters. Acceleration is negative 9.8 meters per second squared. Mathematically, why is that going to be bad?
negative.
You have negative underneath the radical, which leads you to what? Imaginary time. Okay? You'd have to have imaginary time. Great if you're at Disney World, not so much here. So there's a couple of things that you could do. One option is that you just ignore the negative sign and go, oh, whatever. Okay? Negative, schmegative, whatever. Okay? You can do that. Am I going to know the difference? Probably not, but I'll sense it in you. Okay? It's like you're going to walk in and go, you just ignored the negative sign. God, Brookhamp, how did you know?
Jedi.
Don't mean to brag. But, this goes something to Jonathan said. Let's talk about displacement, because this is displacement. So option number 1, you let the ground be the reference point. Up is being defined as positive. So if the ground is the reference point at 0, what's my initial position? 2 meters. Huh. Now, how do you calculate displacement? What minus what?
Final.
Position final minus position initial. My final position is going to be what?
0.
My initial position is, I take 0 minus 2 meters, I get negative 2 meters. Now, that becomes a negative sign underneath there. Now why is that cool?
Because it cancels.
Oh, what's this? Like little fairy things like fly along
Pretty
and,
much.
okay, they cancel out.
They come in
Okay?
and they swap.
Now, in this situation, you can have a negative displacement because you made the ground the reference point, you made that too. You have to view these problems as a tapestry. You just cannot randomly write numbers down and then hope the physics fairies arrive, flap their magic wings, and wow, we'll get the correct value and sign. Okay? I'll swat the physics fairies out of the sky. I'm just telling you. Okay? I'm just saying. It's like, I brought my own physics fairies. No, you didn't. Okay. Rude. Now, there's another way that you can do this problem. You go, Mr. Burkamp, I want the point where I let go of the ball to be the reference point, which is cool. You can do this. But then what would the final position be? Keeping in mind that down is defined as a negative value. Then the final position would be negative 2 meters. Oh. So if you do it that way, what's my displacement?
Negative.
Still negative 2 meters, because now it's negative 2 minus 0. Okay? So if you're consistent on how you set up these problems, it will lead you to the promised land. Now, this is what you're going to do wrong, I promise you. You're going to go through all of this and you're going to feel good about life. You're going, oh, I got you. Okay? And you're going to forget to take the square root of that. You're going to take 4 and you're going to divide it by 9.8 and you're going to forget to take the square root. Okay? Yes, you will. You shake your heads and say you won't. You lie. Okay? It's going to happen. So somebody give me this number.
0.645.
Oh, well, no, 0.6,
0.64.
How about three significant digits?
0.64,
That's two significant digits.
0.63, yeah. 9.
Seconds. Now, here's the beauty of physics, is that that's a predicted value. We could verify it. We could go up to a height of 2 meters and we could drop it and we could see how long it takes to hit the ground. Oh, 2 meters, let go, 1 missa. Okay, so 1 missa, if you convert it, is equivalent to 0.639 seconds. Okay, cool, it matches. Now, if we drop it and we get 1 Mississippi, which is not 0.639, then it's like, oh, our equation is wrong because it took longer than we thought it should. So all physics is trying to do is come up with a way to mathematically determine and describe what's happening in the universe. And you can always verify it. Oh, it's 0.639 seconds, let's drop it. Now, there's a couple of things about gravity. Number one, and physicists are famous for this, if something's annoying, we just ignore it, okay? So clearly, if I drop that piece of aluminum, and if I drop that tennis ball, I get completely different accelerations. So the key assumption that you make when you're dealing with gravity is that there is no wind resistance. Everything is in a vacuum, okay? Because here's the deal, once you start throwing in air resistance, it gets real ugly real fast, because then you have to worry about drag coefficients, and that's a function of how fast it's falling, because the faster it falls, the more molecules of oxygen and nitrogen that you're running into. By the way, never say air molecules, that's dumb, okay? There's no such thing as air molecules. And so they're falling faster and faster and faster, and then your drag coefficient changes and your resistivity changes. So we're just always going to assume that you're falling in a vacuum. In reality, you're not, but hey, it makes the math simple. Okay, so at this point, could we go back to, oh dear Lord, no, I am not in the mood. My screen is like frozen up. Whoa. That got weird. I don't know how a circle ended when they put it on my paper.
It's the same circle, it's not bigger.
It's possessed. It's physics. Okay, here we go. All right, so at this point, the velocity time graph was like this. That had a slope of negative 9.8 meters per second squared. And you got, what was the time point? What, 0.63 seconds. Okay? And we know that area is now consistent. That area is negative 2 meters. So I need to figure out how fast it's going at the point of impact. So could I use the 0.639 seconds to get my velocity at impact? Yes. Now let's talk about that. Is my velocity at impact going to be bigger than negative 9.8? And this is the physics definition of bigger. Like negative 10, negative 11, something like that. No. Is it going to be exactly negative 9.8 because the acceleration is 9.8 meters per second squared? Or is it going to be less than 9.8, like maybe negative 7, negative 6? Shannon, you were all in and less than that. Why?
Has it been a second?
So what?
It can't be over negative 9.8.
Why?
Because it hasn't been a second. Because it goes negative 9.8 meters in a second. Meters per second squared. You know what I mean.
I got you.
You got me.
So at negative 9.8 meters per second, so at the end, if it fell for exactly 1 second, how fast would it be going?
9.8.
Negative 9.8, right? If it fell for exactly 1 second from rest, it would be going negative 9.8. Did it fall for a second?
No.
It fell less than a second, therefore my velocity has to be less than negative 9.8. Okay, so before you do any calculations at all, you know it has to be less than negative 9.8. Now there's two ways you can do this. Count them. Those. One option is that you go V equals V naught plus AT. Okay, you can do this. What's your initial velocity?
0.
0. It's the slope-intercept form. What's your y-intercept?
0.
0, because we dropped the ball. Okay? So my initial velocity is going to be 0. You know your acceleration?
Yes.
Negative 9.80 meters per second squared. You know your time?
Yes.
0.639 seconds. So, Jonathan, do us a favor. Take that 0.639 seconds and multiply that by negative 9.8. Negative 6 something.
Negative 6.26.
Meters per second. Okay? Seemed reasonable. We're going to less than negative 9.8. Here's the downside of using this method. How'd you get the 0.639?
Using one of your previous calculations.
You found that number. I did not give you the number in the problem. You found that number. So if that number is wrong, guess what? Your next answer is going to be wrong. Okay? That's the problem. So if you did what I said you were going to do and forget to take the square root, and you have the wrong time, your next answer is going to be wrong. Okay? So is there a way that I could find the final velocity without using time? Oh, I can use that equation. Two AX, right? I can do this. What's my initial velocity?
0.
0. Now, I'm going to do this wrong. 2 times negative 9.8 meters per second squared times 2 meters. Boo, hiss. Why? You're going to have an imaginary velocity. Cop ever pulls you over for speeding and says, do you know how fast you're going? It's an imaginary velocity. I have a negative underneath my radical. You are going to jail in handcuffs. Promise you that. And don't call me and go, my physics teacher said it was okay to have imaginary velocity. Okay, no, I will testify against you. But again, what's your solution? I make, now what happens? Miracle of miracles, we have positive underneath the radical. But your calculator lies to you. What does your calculator say the answer is? Calculator is going to give you an answer of 6.26 meters per second. Calculator lied to you. Why? Because the velocity is negative. But what's the square root of 4? 2 or negative 2. You just have to do what?
Use context.
You just have to pick the negative root. Okay? So, the advantage of this is that you go off with known values. The disadvantage is that you have to remember to choose the negative root. Okay? The advantage of time is that it automatically generates a negative value. The disadvantage is if the time is wrong, your velocity is going to be wrong. Okay?
Oh,
So-
so if you do this, you have to just know it's negative?
Yes, you just have to choose the negative root. Now, if it was going up, you could keep the positive root. Okay, but you just have to choose the negative root. Okay, why won't this thing move? All right, this is annoying. All right, real quick. Now we're going to do one other problem, and it won't take a huge amount of time, because now we understand the process. Ava, pick a number between 12 and 20.
12 and 20?
18.
Okay, so we're going to throw the ball up in the air at 18 meters per second. Okay, boom, we're going to throw it up. Come back here. 18 meters per second. That's the only number that you know. I want to find the time up, the time down, my max height, the height and velocity at 1 second, the height and velocity at 2 seconds. I want a position time graph and a velocity time graph. I've only given you one number and I want to generate all of this. But hidden within this, what else do you know? So here's the deal, I'm going to throw the ball up in the air.
Acceleration.
What else do you know?
Final velocity
Where?
at the peak.
At the very peak, what's the velocity going to be?
0.
0. So I'm going to go from 18 meters per second to,
0.
is my time up going to be bigger or smaller than 1 second?
Bigger.
Why?
Because 18 is greater than.
Because my initial velocity is bigger than, because if I start at 9.8 meters per second and throw it up in the air, how long is it going to take to go to 0?
1 second.
Exactly 1 second. So since my velocity is more than 9.8, my time up has to be more than
1 second.
1 second. What's my velocity, speaking of velocity time graphs, what's my velocity time graph going to look like? Going to start at 18 and do
Down.
Slow down.
that. Where, this is my velocity time graph. Where's the ball when it crosses 0?
The very top.
It's maximum height, because that's when the velocity is 0. That's it slowing down, stopping, and getting back up. Cool. So, if you look at the V naught tax chart, initial velocity was 18 meters per second. On the way up, what's my final velocity? 0. What else do you know? Acceleration is negative 9.8 meters per second squared. Cool. Let's talk about the time up. How can you find the time up?
First equation.
First equation is V equals V naught plus AT. What do I not know? Time. Solve the equation for time. Okay? Solve the equation for time. Cindy Woodard, what does that equation look like solved for time? The first equation solved for time.
V minus V naught over A.
Beautiful. So V minus V naught over A equals my time. This is why you have to be consistent. Now what I'm going to do is wrong. Oh, imagine I'm doing this over here. I want to take 18 meters per second and divide that by negative 9.8 meters per second squared. Wrong. Why?
Negative.
If you get negative time, just don't ignore it and go, oh, I'll just erase it. It's cool. No, it's not. But this is why you work the problem holistically. What's your final velocity? 0. Now, if I take 0 minus 18, guess what? Now it's all good. Because now I have a negative divided by a negative. So somebody take 18 and divide it by negative 9.8.
1.837.
So call it 1.84 seconds. If it's symmetrical, which in this case it is, what do you know about the time up and the time down? They're going to be the same. If it's symmetrical, and that's a huge if. Now, if I throw it up like this, and then it falls all the way to the ground, I can't set the 2 times equal. Okay? All right. To get the max height, I got to run through this real quick. You're just going to use V squared equals V naught squared plus 2AX. You know your initial velocity, you know your final velocity, you know your acceleration, find X. Okay? You're just going from 0 to 18, there you go. Now, on this one, where you're trying to find the height at a specific point in time, there's only one way that you can do this. To find that height at 1 second, the only way you can do that is do X equals 1/2 AT squared plus V naught time. That's a function equation.
Wait, define what?
Huh? To find the height at a specific point in time.
Okay.
Like if you want to find the height at 1 second, You're gonna come in here and you're gonna put in 1 second for time, your initial velocity of 18 meters per second, your acceleration is negative 9.8. So if you plug in the time of 1.84, you would get your maximum height. If you plug in 2 seconds, so the beauty of this is that it gives you height at any point in time. And then to get that velocity at 1 second and 2 seconds, the only thing you can do there is go to this, because this is just saying, oh, your initial velocity is 18, your acceleration is negative 9.8. Plug in 1 second, plug in 2 seconds, plug in whichever value you want to find the velocity at different values.
Wait, so that one is for a specific height, that one's for a specific time?
Yes, two completely different things. Okay, because I know the Southie people got to get out of here. Let me get this. How cool is that? Okay, now let me give you some hints real quick. 1 through 4 do not use gravitational acceleration. Those are old school. When you get to question number 5, you're dropping a rock off of a building. I tell you, off of a bridge. I tell you to make the bridge the reference point. So you're going to have negative velocities, negative displacement. When you get to question number 16, you're shooting a pyrotechnic up in the air and it's going to explode. Do not use that equation to find out how high the mortar is, because you don't know if it's on its way up or way down. So on 16A, do not use that equation. On number 15, let me give you a hint. Use t square root of x over g. So when you get to number 15, you want to start with that equation. That'll make sense when you get to it. Yes, you have a couple of problems out of the book. Okay, I'm done running, be free. It's just that equation that we solved for.
Dx over g.
Yeah.
It's called academic the g.
I gotta send you for Calc 2. It's a lesson I let yesterday, but I gotta send you for Calc 2, so I don't Calc 2. I gotta get you a section, so.
Yeah, sectional.
That's not bad.
Isaac Bruce.
Well, they guess. He's got a lot. They guess. I don't understand what
I don't know what answer here. The answer he's showing them.
You actually have the answer?
No, he didn't have an answer. I don't know what he answered. The answer here on something. Like a week ago. Like I think it was like
You won't be here at all.
he was big chilling. He was gone for 2 days. What did you do?
Thoughts as I were doing the review. Okay, I'm gonna leave the copies of the review in Mr. Rankin's mailbox.
Okay.
Tell him to get them, because I don't have them run off yet.
Okay.
So they're gonna be in his mailbox, your responsibility to do it. Okay?
Ready also.
Huh?
Ready also. I'm also gonna be gone.
Okay.
Yeah. Just Be fair, it's a square. Beware, that's what
Square, I think it's really.
What's the point of that?
okay. Okay. Yeah, I think you can do it, it'll be a square. Wait.
That's almost a square, like, no, figure straight. And then I here.
You can use that's a square. I bet you paid for it.
Okay.
Like that.
So,
I know you would pay for it.
that's not what happened. No, I'm just getting my money for it. It's not even money. I'm just getting my money for it.
Jocelyn, nice spell.
I did multiple of them.
Huh?
I did multiple of them.
Okay. Yeah. You gotta do it like a flip book where it's like separate and then it just like comes together like when you flip the pages. Brady, is this a scarecrow sliding in?
No, that's a person.
I'm not sure
Okay.
about that, dude.
What? It looks like a scarecrow. Guys,